In today's session, I will discuss about this sizing of HANA database. So, what is general procedure they follow when it comes to SAP solutions? See, when we are speaking about sizing, the first and foremost thing you need to identify is what kind of project you're going to deal with. That is most important thing, first and foremost. So, it can be a new implementation, or maybe you're looking at doing a migration. Existing SAP application you're trying to migrate to HANA database. So that you need to understand, identify first. Just S for HANA is just an example. It can be anything. I'm just taking an example there. A new SAP HANA implementation or doing a migration. So you can't follow the same procedures for sizing. Approaches will be different. As of now, we are going to limit ourselves only for a new implementation. Only new implementation. Later on at the end of the training, we are going to have a couple of sessions on migration. At that time, I'll discuss about how to do the sizing for migration projects. So a simple point, remember, if it's a new implementation, what we call it as greenfield sizing. The greenfield sizing you'll be doing with quick sizer tool, which generally you follow. You know, the tool which we use for any SAP application implementation, maybe ERP, CRM, BW. So you might have used quick sizer. If you have seen this quick sizer, maybe in the last 3 years time, you might observe that quick sizer, when they're providing two versions for you. One is quick sizer classical version, another one is quick sizer we have HANA version. The classical version you'll be using when you want to implement SAP solutions with RDBMS, whereas the HANA version when you want to use or implement SAP solutions with HANA database. So they have a clear separation because the sizing approaches will be different, and that's why they given it separately. Okay, now if you want to do the sizing, if you are speaking about a greenfield implementation, you want to go with a greenfield sizing. So what are the different factors you have, or what are the different factors we need to consider? Always one standard rule, remember here, SAP will give you a lot of information, a lot of documents they'll give you, a lot of notes they'll refer to. Try to gather that information as much as possible first of all. And then based on the recommendations given by SAP there, follow those recommendations. Based on the recommendations given by SAP, try to do the sizing, because there are so many factors which will affect your sizing. And that's why no one can give you hard and fast rules here. No one can tell you that exactly, okay, this is what you need to follow. Even SAP can give you only the recommendations. You just need to follow the recommendations. So that too, remember that when we are doing sizing, which may go completely different in a wrong direction, unless otherwise you handle it carefully. Because sizing you need to do based on some facts and based on a lot of assumptions. Understand what I'm saying? I'm saying only some facts but a lot of assumptions. So assumptions you don't do it properly, it's a lot of possibilities that you end up with wrong sizing there, you end up with a lot of issues in the performances and all. So that's why you need to consider so many different factors here. Information given by SAP, read through all that. Don't consider them as rules, always consider them as guidelines given by SAP. and depending on the situations there in the company and the customer's place, you change it accordingly. You adapt to that guidelines according to that requirement there. So the first and foremost thing when you're thinking about doing sizing for SAP HANA, what you have to do is, so first you go to this help.sap.com website and try to search for that HANA platform. Okay, here a lot of documents you have. Version 2.0 you have there. So in this, once we click on that view all, we just come down. So this is what you need to refer to. There is HANA sizing note 1514966. This will give you a lot of information which you need. That note will give you a lot of information, a lot of guidelines they'll give you, and the quick sizer for SAP HANA. So it will provide you information about how to size SAP HANA, and depending on what kind of solution is that. So once you have done the sizing, then we'll look at the hardware partners. What are the models we have? So all that concept comes into picture. So if you are someone who is completely new to this, you don't know how to use quick sizer, you have never seen quick sizer, there's a beginner guide available here. It's a simple PDF document which is already there in the Dropbox. You can refer to this one. But refer to this note first, 1514966. Okay, that's the first thing what you need to do. A lot of guidelines you have there. Okay. So what are the primary factors here when it comes to sizing? What are the primary factors and how it's different from your traditional database sizing? So definitely approach will be different because HANA sizing, when you're speaking about the most important thing here is the memory, because we are speaking about in-memory database. So obviously identifying the memory is so important here. So that's why they mentioned that memory is the leading driver for HANA sizing. But apart from that, you have those standard KPIs, the key performance indicators we have. So memory, CPU, disk, and the network. So all these plays a vital role. I mean, it's very important for you to take care of all these things. You need to identify the right kind of memory required. So for that, a lot of considerations you are going to have, which we'll discuss now. And then the CPU, the processor requirements, how you have, depending on the type of application you are implementing, whether it's native HANA or maybe ERP on HANA or BW on HANA, CRM on HANA. So depending on whether it's OLTP or OLAP, so we need to identify the processor requirements. Then you know that part of the architecture itself, you have persistent storage, which is so crucial. So to keep the data safe, we need to save the data in the disk. So obviously there is a requirement for the disk storage here. So we need to find out that as we discussed earlier in the architectures. So I explained you need to have the disk storage for data volumes, disk storage for log volumes. Even the traces and all that, you need to save the trace and log files. Even for that also we need some additional disk space. So network also plays a vital role that you need to choose it carefully. Otherwise, if we have too much of network traffic, if you don't have high bandwidth there, definitely it will affect your performances. That's also another thing which you need to be really careful. And that too, particularly in a situation where customers may end up with one single HANA database on multiple hosts, which we call it as distributed database. So, or multi-node databases. In such cases, the network communication between those nodes is also very, very crucial. That that affects your performances a lot. So all these need to be taken care of properly. So if someone asks you what are the KPIs when it comes to HANA sizing, these are the main major KPIs for you: your memory, CPU, disk, and the network. But out of those the KPIs you have, memory is the leading factor for HANA sizing. So mostly HANA appliances, they'll decide based on the memory requirements. So coming to the next, there are some standard applicable statements on sizing which always you need to consider when you're doing the sizing. Generally people won't think much about these things, but you need to think about this and look at these statements which are very, very crucial. So as is mentioned, it's OLTP application. If you consider 20% of the transactions in their scenarios create 80% of the workload. So focusing on the 20% is very, very crucial for you. Generally people won't look at that. They'll generalize everything. So, but that's a fact. Only 20% of the transactions create a maximum of the load on the servers. So another thing is always when we are doing sizing, we should have the flexibility, because we cannot be so specific. We cannot pinpoint that saying that okay, exactly this configuration is going to work for this company, because there are so many variable factors here. So that's why no one can exactly say, okay, this is what the configuration is going to work out for this company. That's why always the customers will look for scalability. Scalability both the ways, the software as well as the hardware. So that flexibility they look for. Anyhow, that's not a problem as far as HANA is concerned, because our HANA database server software is scalable, as well as the appliances, the hardwares they're providing are also scalable. But when you're choosing the appliance itself, you need to choose the right appliance, because there are some appliances which supports only scale up. There are some appliances which support scale up. So those appliances where you're looking for scale up, you have to choose them the right way. Otherwise what happens is actually that appliance is meant for scale out. You bought that appliance, you're thinking about scaling it up, it doesn't work. There's no facility for you there. So I'm going to show you those appliance models, you'll understand. So whenever you see those appliance models, for every model they'll write clearly, okay, whether this appliance model is for suitable for scale up or suitable for scale out. Clearly they'll mention that. Okay, you may have a doubt what is that scale up, scale out. Most of you people might be knowing that, but still if you have a doubt, scale up, scale out is something like this. So suppose uh, say example, you bought a laptop, a new laptop you bought now. Suppose as of now your requirements are very limited, but you know that after some time in the future your requirements may increase, maybe the memory requirement or something like that. Say you bought a laptop with you want laptop with 4 GB RAM, but future definitely there's a possibility that you are going to run some applications which may need some additional 4 GB RAM. So what we have to do is of now to keep the cost low and to have a suitable hardware there, what you can do is you can buy a laptop with only 4 GB RAM but supports up to 8 GB. And that's important. When you buy the laptop itself, you need to ask them, okay, does this support 8 GB RAM or not? So they'll give you clearly. So already installed is only 4 GB, but it can support up to 8 GB. So then the flexibility you'll be having is today you bought a laptop with only 4 GB. Tomorrow you can upgrade it to 8 GB. It can. I mean, because it's having that compatibility, that facility there. Otherwise, you bought a laptop with only 4 GB RAM, which supports only 4 GB. Tomorrow you want to upgrade to 8 GB. That's not possible because those motherboards and all that matters there. That motherboard supports with limited memory. So that's what scale up is about, increasing the configurations vertically. On the same machine, you can add some more additional RAM and you can just increase the capacity of that. It's something like, let me show you one appliance model I have here. The box, how it looks like, I'll show you. See this box here? So it's clearly shown that here main memory is 256 GB installed, expandable to 512 GB. So actually it's maximum supported 512 GB they have, but out of that only 256 GB they installed. So there is a possibility of upgrading it to 512 GB. That's a flexibility you have there. So that kind of flexibilities we need sometimes where the customer will look for it. So that we call it as scale up. But suppose I want to have 1 TB on that appliance, not possible. So in such cases what you do, you can go with the scale out. Scale out means you can add one more additional system like that. So you call it as clusters. Similarly, here for the same HANA database we can maintain multiple nodes. So and that way also we can increase the configuration of this. So effectively you are increasing the capacity of that database. So scale up is increasing the configurations vertically. Scale out is increasing the configurations horizontally. So that flexibility we need, that they're providing, so that we don't need to worry as far as HANA is concerned. There's very much is there. We have software supporting is there, scalability, as well as hardware support also is there. KPIs has already explained you. And you always think about landscapes. Okay, landscapes in the sense it's not just one single system. In an implementation environment you want to have a dev database, test database, and then production database. So what SAP recommends generally is they'll recommend you to go with this. Say example, one box you see on the left side, one SAP HANA box for dev and test databases, and one HANA box for production. So when you're doing sizing, you need to be very clear, okay, are you doing it for production? We do it for production. But we also need something for dev and test databases, so a separate box we need, and that also you need to identify. So that identification is also important for you. So landscape related information you need. So those are general things, general statements. Now coming to the project risks. The biggest mistake what generally we do is, as I mentioned, there are some facts and a lot of assumptions. Those assumptions when you're doing, you need to validate those assumptions really. Okay, I'm doing this assumption, is it valid or not? Okay, is it really valid? What you have to do is you need to document that assumption. That's so crucial because tomorrow you need to document in a way, such a way that saying that clearly, based on these assumptions I've done this sizing and final result is this. So that's very, very crucial. So if you don't do that, if you don't document your assumptions, the biggest problem you'll be having is you'll be giving some sizing results to them, and tomorrow if they have some problems, they'll point fingers at you, and you can't answer that. You can't simply say that I did this because of based on these assumptions, because that should be documented properly. So assumptions are not verified. So while it's perfectly okay to work on assumptions, you must ensure that the verification process is included in the project plan. So verify what is that assumption and on what basis you are doing that assumptions. That's very, very important for you. And incomplete input data. So get proper information from the customer. So getting that information is so crucial for you because sometimes wrong information lead to wrong sizing. So there should be sufficient information you are getting from the customer. So all that is mentioned here, clearly mentioned that often caused by communication issues. When there is not sufficient data available, assumptions must be made and documented. It's crucial. So, and another thing, custom coding and special data consolations. Generally, we can't predict this. I mean, we don't know whether exactly that custom coding is needed or not. When we can come across that, okay, when I'm starting implementing, so implementation started at some point, there's a complexity involved. So because of that complexity, whatever the default facilities you have not sufficient, the graphical options, I need to do some custom coding and all that. So that will be difficult to predict, but still making sure that there is some verification process for that. So accordingly, you need to do the adjustments there. So that kind of flexibilities you need to have. So you need to consider these kind of risks involved there in the sizing projects. So otherwise, whatever you do, and tomorrow they'll say, okay, this is a problem. This problem is because of the sizing you did. So every time they'll point towards that sizing only. Even if you have a small performance issue, also they'll point fingers at you. So that's why you need to be a little bit careful there, and whatever information they are giving, note it down, and whatever the assumptions you are doing, note it down, document it into sizing, and always be liberal when you're doing sizing. Give a little bit more additional memories, additional spaces and all that, which will be always helpful for you. Like say example, I did some calculations, I ended up with say 200 GB RAM requirement. Anyhow, you won't find appliances with 200 GB RAM. It's something like you want a shirt, have a shirt with size 42.5. No one will give you. So there will be some standards, but in such cases we'll recommend, okay, 200 GB, better go with 256 GB RAM. Because nearby there will be some that 192 GB, that kind of RAM servers also, but we don't recommend that. Better to go for the next one, the higher one, 256 GB, ideal. Okay, so these are all the things you consider. Refer to the notes what SAP has given based on the kind of solution for which we are doing the sizing, and then proceed with that. See, to understand this, the sizing calculations, how they do it and how it works, I'll give you a small example, a simple example. Suppose we are going with native HANA as a warehousing solution. If you remember, I explained you the landscapes for that. Take the example of this customer. I've shown you this beverages company. So where they did SAP HANA implementation. But suppose for this customer we want to do sizing. So this is what it is. See, on the left side you can see the sources. In the middle you have HANA database. On the right side we have reporting. So the point here is now from these different sources, data need to be replicated into HANA and store the data in HANA. So obviously when you store the data in HANA, you want to store the data in memory. They can consider that, the big data solutions landscape also, which I explained you by using smart data access, storing a portion of the data in outside HANA database in nearline storages. That also they can opt for. But if they store the data outside HANA database, that I'm not worried. I'm not interested in that. What matters for me here is when I'm doing sizing of HANA database, I'm interested in the data, what I'm going to store in HANA. So that I need to know, that's it. Customer may have, large chunks of data. I'm not worried about that. The data, what they are going to store in HANA is what matters for me when I'm doing sizing. So if this customer in this particular scenario, assume that I ask them, okay, what will be the volume of data in the source systems which I need to store in HANA? So they'll give you some numbers, okay. There may be some people working on the source systems, they can give you that information. Maybe some administrators can provide you that information, which I'm not concerned. They have to provide the details to me. Say example, they identified there is 700 GB of data. What is this 700 GB? This is what we call it as source data, or you want to be more technical, you can use the term source data footprint. Total source data what we have. But another important thing we need to consider here is whenever you identify the source data, always identify the uncompressed source data. So always identify the uncompressed source data size. Because the problem generally the mistake what they do is they don't consider the fact that when the data is coming from some Oracle database or some other source, there is already some data compression happened, and that kind of data you're trying to load and thinking about getting even more higher compressions not possible. So SAP will give you some compression recommendations based on the fact that we are applying these factors based on the uncompressed source data. So always find out what is the size of uncompressed source data footprint. Example, I've taken 700 GB. Now when we want to store this data in the memory in SAP HANA, imagine if I want to store 700 GB data, if I need 700 GB of RAM. 700 GB data, you want to store 700 GB RAM, you need, it's too expensive. No customer will be interested. No customer. No one will be interested in that kind of product. Who will be? So much of money they need to spend. See, always think about the cost factors also. Cost of storing the data in the memory is very, very high. If people are having any doubts about the cost of storing the data, you don't need to think too much on that. Only no one need to tell you that. A simple example, you spend 5,000 rupees, you'll get, say, 8 GB RAM. The same 5,000 rupees you spend, you'll get 1 TB hard drive. Compare this too. Compare storing the data, cost of storing the data in the disk. 1 TB data you store in the disk, it's costing 5,000 rupees. But if you spend same 5,000 rupees, you are able to just store only 8 GB data in the memory. So obviously it's very, very expensive storing the data in the memory. So you can't simply ask the customer, okay, buy a 700 GB RAM machine to store 700 GB data. It's too expensive for him. No customer will be interested. And that's the reason why SAP has implemented, when it comes to storing the data in memory, SAP has implemented a lot of storage techniques, specialized storage techniques. Actually, yesterday I've explained that, if you remember, the column store, how the data is compressed and all that. So because of which, when we store the data in SAP HANA in memory, data will be automatically compressed in a big way. I'm saying data is automatically compressed, means I don't need to ask the system, I do the compression. So that's done automatically. The dictionary maintenance and all that, we can call it as dictionary compression. So SAP has experienced so many different things in a long period. What SAP is ideally suggesting is, if you are going with this kind of solutions, whatever I'm showing you now, uh, the landscape like this is the landscape where only standalone HANA database, native HANA database you have. We don't have any application running on top of that. So in such situations, native HANA, when you're using as a data mart or a data warehousing solution, so the compression factor, what average compression factor, what SAP is recommending is 7 times. Average compression factor, I'm saying. So 7 times compression, when I say if I want to store that 700 GB data, effectively I need only 100 GB RAM. 7 times compression means it's a very big thing actually, a huge compression. But you can't expect the same when solution is different. Like instead of this as a warehousing solution, 8 HANA as a warehousing solution, if customer is opting for say BW on HANA as a warehousing solution, that is also warehousing solution only. There also they're going to store the data, but if they use BW, they install BW on top of HANA, then you can't experience the same kind of compression ratios there. Reason is whenever BW is used, they build data models at BW application level. They create something called info objects. Whenever they create those info objects, underlying tables generated will be row store tables. Whereas info cubes, DSOs and all that, when they create, there will be column store tables. So as there are significant amount of tables as row store tables there, you can't experience this much of compression, because this much of compression is possible if you store the data in column store tables. So that's why SAP recommendations will vary. If you go with the BW and HANA, then you refer to that note, whatever I given to you, and a lot of notes I given here in this document also. I refer to a lot of SAP notes here. So sizing report for BW on HANA. So when you are implementing BW on HANA, what you have to do? So what are the options we have? All that explained there. So you can't go with that kind of compression, because average compression factor SAP recommending there when you are implementing BW on HANA is only 4 times. They'll give you clear statement. They'll give you, see this, BW on HANA 4 folds, because BW has significant part of its tables in the row store. So that's why you need to be careful. You need to always think about the solution first and then follow the guidelines given for that particular solution and do the sizing accordingly. But now whatever the RAM you identified, say 100 GB RAM in this example, this is sufficient for storing the existing data. Right? Existing data means already in the company we have data that is already existing. So that is fixed. That's not going to change. So storing that existing data. So that's why we call this as this RAM, whatever we are identifying here, that we call it as static memory or static RAM. This is just terminology. I mean, there are some people getting confused with, what do you mean by that? Is there anything different memories you are going to get? Nothing different memory. Your physical memory and all that will be same. That you don't worry. It's just terminology what they are using. Static memory is nothing but the memory which they can utilize for storing the existing data. The memory what they identify to store the existing data. So this is sufficient for storing existing data. Is that sufficient for running and operating your database? Answer is no. If you buy a machine with 100 GB RAM, I'll be able to store the existing data. What about new data? Where I'm going to store the new data? It's not that you're going to have only 700 GB throughout the lifetime in the company. Today you have 700 GB. Every day some new transactions, new business is done, new transactions performed. Obviously you'll get some new data. And that data also need to be loaded into your warehousing database. That's your HANA database. Obviously it has to store the data in the memory. So we need some additional memory for that. And apart from that, it's not just about loading the new data. And apart from that, once you store the data in HANA, what we do? We have to do some processing. End user will request for the data. So we have to do a lot of processing. As part of the processing system will generate a lot of intermediate result sets. All that need to happen in the memory only. So we need some additional memory for 2 things. One, for storing the new data, as well as for doing the processing. Any query processing or request processing if you want to do. So we need some additional memory, and that they are referring to as I call it as dynamic. So dynamic memory is nothing but the memory which we can utilize for storing the new data as well as for processing purpose. What SAP recommends is dynamic memory equal to static memory. This is SAP standard recommendation, means whatever the memory they identified for that's storing that source data footprint, same amount of memory they're asking us to allocate for dynamic activities also. So if it's 100 GB RAM there, so another 100 GB for this. So people may argue sometimes, hey, on what basis SAP is saying that if that is not sufficient, what happens? See, these are all general assumptions, like you are using your system for some time period now, maybe for 3 years, 4 years. So you can't expect suddenly things will change and you'll get huge volumes of data all of a sudden. So that won't happen. That's why that is general recommendations what SAP is giving. So some situations they may say that, okay, this is not enough for me. Fine, if it's not enough, you go for higher configurations, you go for bigger RAM. That's why I told you these are not rules, your recommendations. You don't want to follow the recommendations, you want to buy a bigger appliance, it's fine, you buy the bigger appliances. But always you need to think about that initial cost also. See, you can't have an assumption that after 3 years I'm going to have this much of huge requirement. Because of that I want to buy an appliance with high configuration now. It doesn't make any sense. Why to invest so much of money right now itself? When you have that flexibility of scalability, you can scale it up or scale out depending on your requirements later on. When we have that comforts available for you, let us keep it too low, because to an optimal level, if you can keep it, you can control that cost. The initial investment goes into this, which always customer will look for. Okay, so there may be some exception situations where it may not work out, because say maybe some merger is taking place. One company has taken over another company. When merger is taking place, all of a sudden all that data also comes into this. In such situations, this may not work out. You need to consider those exception situations and accordingly you need to act. But these are the standard recommendations what you find. That is, what is the standard recommendation? RAM dynamic equal to RAM static. That's a simple formula. This is RAM static. That is source data footprint by 7. And RAM dynamic equal to RAM static. So this dynamic memory what we are speaking about for loading new data and executing queries. So the total RAM requirement is RAM dynamic, RAM static, that is source data footprint multiplied by 2 by 7. So for this customer, you can say the total RAM needed is, say, 200 GB. That's how you identify. But as I did mention that you won't find appliances with a 200 GB RAM exactly. So you need to choose a nearby suitable model for you, nearest to this configuration. Like we recommend to go with 256 GB RAM, which is ideal for that customer. So this is how they do it, identification of the RAMs and the calculations performed. See, sometimes they may experience even more. Actually, uh, when you're doing migrations, you don't experience this much. The fact is, particularly BW kind of applications, I told you, right, 4 times. But there will be sometimes surprising things will be there. Like you take an example, this project you take, this Osha International. Actually, this company is one of the early ramp-up customer for SAP HANA. They did a migration. So generally what we expect, say 4 times compression we expect, because there's a BW application. But let us see what are their experiences are here when it comes to the compression factor. See this? This is a compression what they experienced, 419 GB, that is BW with the DB2. Once they migrated to BW on HANA, it came down to almost 47 GB. Overall compression factor they experienced is 9 times overall. because a lot of things completely removed. No need of indexes. Each column in your column store table will act as an index. So no need of indexes. They are not migrated. Obviously, all that is eliminated. So these GSO change logs are not migrated. Absolutely. So because the one customer is experiencing 9 times, I cannot recommend, okay, go with 9 times. Whatever the average compression factors they have experienced, that SAP is giving, SAP is suggesting. So those factors only will consider. Because for that particular solution, they'll give you, as I told you in the SAP notes, whatever the node they are referring to, if you go to that node, that information will be available for you. Okay, once you identify RAM requirement, now in this case it is official 256 GB. Okay, they'll go with the 256 GB RAM machine. Next thing is, the persistent storage. We need disk storage. The storage is basically separated into two parts. You're having data volumes and log volumes. As I clearly explained you, log volumes always will be limited in size, but data volumes keeps on increasing as and when data volumes increases. This data size increases. So recommendations as far as disk is concerned, data volumes, what they're recommending is 3 times of RAM. When you buy appliances, when you procure the appliances from the hardware vendors, this is what we recommend, 3 times of RAM. Because sometimes in your database copies and all that you're doing, it has to create images and store there. All these things will be there. So you need 3 times of RAM for data volumes. And log volumes recommendation is equal to RAM. It's equal. But I did mention that what is that exact data we are going to store in the log volumes. If your RAM is 1 TB, we don't need 1 TB log volumes. If RAM is 2 TB, we don't need 2 TB log volumes. Reason is, you always consider the fact that the log volume should be able to, are capable of storing data from one save point to another save point. Suppose your save point interval is 5 minutes there. Within that 5 minutes, how much data you'll get, how many transactions they do, how many changes they do. So based on that, log volumes can be decided. So usual recommendation by SAP is equal to RAM, but it doesn't mean that if you have very high configurations, you have to have the same log volume size. Generally, in any company, it doesn't exceed 512 GB. Any company doesn't exceed 512 GB. Okay, so that's another thing, and you need some additional disk space for traces and logs, because generally whenever we want to monitor the database in a right way, a lot of times we'll activate some traces. There will be some default traces already activated, so a lot of files will be generated. Whenever you do an activity, log files will be generated. So for these traces and logs also we need some additional space. SAP recommendation is equal to RAM. This is general recommendations as far as the disk is concerned. Disk size for persistence layer is 4 times of RAM. The space does not cover requirements for backups. Disk size for log files and operational disk space is equal to RAM. So total the requirement will be, say, 5 times of that RAM. That's the recommendation. And that too, What we suggest for log volumes is better if they can have SSDs. It's better to use solid state drives for log volumes. We generally recommend it because writing the data into the log volumes is a synchronous process. A synchronous process means whenever end user does a transaction, it has to write the data before he gets write the data into the disk before he'll get a confirmation message. So to improve the performance of the transactions there, to make it more efficient, we recommend SSDs for log volume. Some places, even they ask you to go with SSDs for data volumes, but it's going to be too expensive. That's why generally when you see these appliances and all that, they refer to that SSDs, solid state drives. SSD is 1 TB SSD data volumes. So this is generally when you procure your appliances from the certified vendors, the standard configurations. But there will be another situation also which I'm going to explain you. I mean, we are going to continue this discussion even tomorrow. There will be situations where customers want to use their own storage spaces. Like customer is having big data centers already available in their landscapes. So they want to utilize those storage spaces there instead of having this or utilizing the storage in your appliances, which is a bit expensive. So they want to, in case if they want to utilize their data center storage, then we don't recommend this much. Then the recommendations will change again. Because when you are speaking about your data center, everything will be in your control. But when you procure the appliances, that's not in your control. If anything needs, you need to contact the hardware vendor. Because whenever we take when we buy the appliances, generally we buy the appliances with, service also. So usually that's a 3-year service model will be there, which generally we recommend. Yes. That's 3-year service plan. So everything they have to do. Tomorrow, if I need some additional disk space also, they have to take care of it. You can't just open it and plug it there. That's not allowed at all. So that's why you don't have that much of flexibility there when it comes to increasing that, particularly the storage spaces. But when you're your own data center, when you're utilizing, so obviously there will be a lot of flexibility for you. That will be all in your control. You can change whatever you want, whenever you want. So that's why those recommendations will vary. So I'm going to discuss about that separately. There is something called TDI, Tailored Data Center Integration Situations. I'll explain you those concepts also. Okay. So still there are a few more things which you need to know about this. It's not yet over. We need to understand the processor requirements. Again, coming to the processor requirements, it purely depends on whether it's OLTP or OLAP. OLAP demands will be purely based on reporting users, whereas OLTP will be transaction users. So things will differ. So that we have to discuss. And then I'll explain you the TDI scenario. And then I'll show you what are those appliance models, where we can find those list of appliance models. There are more than 1100 models available. I'll show you that list. You can explore them there. And there itself we have certified storage solutions available. Cloud options also will be available. And that also we can have a look at. So those all things we'll discuss in tomorrow's session. And then further, if you have any doubts, so we'll discuss on those doubts. Then we can proceed with our installations and all that. Okay.